everyone. Thank you all for joining us today for this Partner Solution Series 5.2 channel update. Before we begin, I want to share a few housekeeping notes. On the top right of your screen, you'll see a docs section. This has a ton of relevant documents and links for you guys to use, so please feel free to check those out throughout the session. These will be available to you during the presentation and post-presentation as well. We do get this question a lot, so I do want to touch on this. Following this session, we will be sending out this recording within 24 hours, so keep an eye on your inbox tomorrow for that link. If you'd like to also check the partner portal, that's where that link will be hosted. So feel free to go ahead and check that out post-event. Lastly, if you guys have any questions during the session, please put those in the Q&A section. You will also see that in the right-hand corner, close to that doc section. Your questions will appear once it has been approved. If you'd like to submit your question anonymously, you can do that by checking that hide name box at the bottom of the panel. We do want this session to be as interactive as possible, as typically these channel partner sessions are. So feel free to ask any questions and share your thoughts throughout this presentation. Today, we're really excited to share an in-depth look at 5.2, and we'll also be sharing an exclusive preview on the upcoming 5.3 release. This is going to be a jam-packed session, so let's go ahead and get started. It's my pleasure to introduce Greg Michon, our VP of Worldwide Channels. Hi, Greg. How are you?
Christina, I am great. I appreciate the introduction. A perfect job. And so good morning, good afternoon, good evening to all of our vast partners, wherever you're joining us from. We sincerely appreciate it. And we're, as always, grateful for our partnership with you all. Welcome to the Vast Partner Solution Series. For those of you I've yet to meet, as Christina said, my name is Greg Michon. I have the good fortune of leading Vast Global Partner Go-to-Market and the fantastic team around that is covering our partners on a global basis. I also host this Vast Partner Solution webinar series on a monthly basis where we bring together various internal as well as external subject matter experts monthly to discuss really important topics. And today I am joined by, as you can see, a few key thought leaders inside of Vast within our product team, including Howard Marks, Dave Graham, Tomer Hagee, as well as Jonathan Hayes. So guys, welcome. Appreciate you joining us here today. And you're going to note that for our audience, you'll note that with the exception of Howard, the rest of us have very vanilla flavored job titles. Howard, on the other hand, is granted the fantastic title of technology extraordinaire and plenipotentiary, which is typically a person, I had to look this up, a person invested with the full powers of independent action on behalf of their government or entity that they serve. So Howard, that absolutely forces me to ask the question, for a friend, of course, what powerful entity has granted you these powers?
Our CEO, Renan. So I am empowered to act here Vast.
I love it. I love it. All right. Well, welcome once again, Howard, as well as the rest of you gentlemen. So as Christina said, we are devoting the next 40 minutes to going into a lot more detail on Vast's recent announcement of our 5.2 software release. For those of you that joined us in October, you may have remembered Dave Graham, who's on the call, joined us for about 10 or 15 minutes and gave us a sneak peek on 5.2, but we really didn't go into a whole lot of detail. We're going to change that and do that today. So this is more of a technical discussion. So if you're in a sales or a business side, oftentimes you may find yourself looking at your solitaire mobile app once we get into a technical discussion. And if that happens, please, before you tune out and get too distracted, grab your SE or your solutions architect, bring them into this webinar, and then go about your business. I promise you there's a lot of good stuff to share with you all today. So with that, let's turn it over to you, Howard, and let's talk about what's in our 5.2 software release.
Sure. So, from the 30,000 foot view, we've broken this up into updates in various aspects of the product. And the biggest changes relate to the general DACE architecture. We're extending DACE out to support a new component we call the eBox, E for everything box, that combines the functions of C boxes and D boxes. We've, along with the eBox, made changes to the way we process SCM that result in yet another doubling of write performance. So over the last 2 releases, we've got about a 4x performance increase for writes in the cases that our customers care about most. And then across the various components of the system, we have updates in the data store relating to S3 event publishing and extending quotas and QoS to tenants. We have updates in the data space where we now support synchronous in addition to asynchronous replication. We're extending the global namespace to give you some control over where data lives and how data is prefetched. We're extending the VAST on Cloud offering from our previous single instances to full clusters in GCP and later in other cloud providers. And we've added a function to automatically import tables that you have stored in Parquet into the VAST database, simplifying that whole process and eliminating the need for some ETL steps when all you really need to do is import the data. The most significant change is the eBox. We've talked about DACE a lot and how DACE is the disaggregated shared everything architecture. And we've compared that to a more traditional shared nothing architecture. But D-boxes are unique hardware, and we work with our manufacturing partners to produce them and make them economical, but they're not universally available. In order to be able to work with more server vendors who want to work with us, in order to be able to get in on deals that include GPU servers, and in order to be able to operate in the cloud where you can't say, well, what you need is this HAJBOF, we've adopted the eBox architecture. eBoxes run both C node and D node containers to make the SSDs in that x86 server available to all of the C node processes on the other eBoxes. Just like SSDs in D boxes, the C node process on an eBox does NVMe over fabrics directly to the SSD it wants to speak to, whether that SSD is within that eBox or in another eBox in the cluster. So everything is still shared. We've just packaged it in standard x86 servers because some sets of cloud customers only want one model of server in their data center. They don't want unique hardware. And because this model works very well at scale. So our first partner is Supermicro. It's a 1U server with an AMD Genoa CPU and 12 total SSDs. Some of those are SCM, some of them are capacity SSDs, just like when we build D boxes. In the cloud, we have single server instances in AWS, and we have clusters in GCP that we'll talk about again when we talk about clusters in GCP as a database enhancement. So D boxes, because we had a high degree of availability between the SSDs and the NVMe fabrics, could treat SSDs as the failure domain. And we could do wide stripes across SSDs because we knew those SSDs would always be on the network. And that made them much more efficient for small clusters. With e-boxes, we can't be assured every SSD will always be attached to the fabric. So we use the dbox HA data layout so that if e-boxes fall off the net, the system continues to run because we've limited the number of strips of each erasure code stripe on each e-box. At scale, that's very efficient. It's not efficient at small scale, and so we started with dboxes. E-boxes target large clusters. There's a minimum of 11. Don't confuse this with a Cumulo competitor for the little offices. But it does get us out into those additional market segments.
Yeah, perfect overview. And it looks like, okay, so minimum config 11 nodes. For our partners out there, couple comments on this. First of all, the e-box architecture is available today through our partnership with Supermicro as an on-premises e-box solution and architecture. We've obviously, as it notes here, we've also added Google Cloud Platform. So this is available in GCP, which we're announcing. And it looks like I was not aware, but it's same thing for AWS as well. Is that right, Howard? For a public cloud solution?
8 clusters in AWS are coming.
Okay,
they're not in the first 2 weeks.
Fair enough. So I know there are many partners on this call who work with Supermicro, and for you, we can begin selling this solution and architecture today. In fact, we've already done so at massive scale with several different customers. So let's get after those cloud providers, those large environments where perhaps performance density, sustainability, ability to be able to scale are key factors. And oftentimes, like with a Supermicro, it's these server vendors that are kind of on the front end of some of these large environments, these hyperscalers, these cloud providers. So we do want to be working together on really satisfying those customer needs. If you're not a Supermicro partner, but you see an opportunity to be able to position this solution, contact your regional VAST channel account manager or me. You've got, I think, my email address, gm@vastdata.com, and we'll get you aligned with Supermicro. Finally, these are the first examples of the e-box architecture, and they offer just more customer choice, where customers have standardized on a particular server vendor. We'll be further expanding that customer choice by standardizing on other server platforms to be announced in the coming months.
Thanks, Greg.
You bet.
So now let's talk about changes to how we've used SCM in VAST. Right? Traditionally, we treated SCM the way storage systems have treated their high-performance memory since time immemorial. We mirrored it. Every time data came in, we wrote it to 2 different SCMs on 2 different dboxes. If you had 2 different dboxes, if you only had 1 dbox, we made sure it went to 2 different SCMs connected via different D nodes, all about maximizing availability. The SCM holds 2 different data pools. About 80% of the SCM is used to hold system metadata. About 20% of the SCM is used to hold the write buffer. In both cases, this mirroring was just mirrored by 128K pages. And writes to the write buffer were treated basically as a first in, first out list with writes as the IO size. So if it's a 16K write, we wrote 16K. If it's a 1 meg write, we wrote 1 meg. The problem with mirroring is twofold. The first is that it turns out the performance bottleneck in a vast cluster is almost always the bandwidth between the NVMe fabric and the SCM SSDs. By mirroring our I/O, half of all that I/O or all that bandwidth is used for the second copy, and so 50% overhead. The other problem is when we're mirrored, we're only protected against one SCM failure. When SCM was always in a highly available D box, that was sufficient. But ENIT boxes are just x86 servers, and they're going to fail at a higher rate than D boxes that require both D nodes to fail before an SCM SSD falls off the network. So we needed a higher level of protection. So in order to fix that, we're moving from an N+1 mirrored protection set to an N+2 protection set where we can have 2 SCM failures without data loss. We're going to erasure code the data in the write buffer, and we're going to triple mirror the metadata because the I/O patterns of the write buffer and metadata are very different. So write buffer erasure coding, which is also sometimes known as write buffer RAID, appears in VAST 5.1. We're writing data to the write buffer using Reed-Solomon erasure codes, generally 10+2. On the smallest clusters, it can be 6+2. That means there's less overhead, so we have more bandwidth for data. 5.1 also includes some improvements to write buffer locking. The net result is that the write bandwidth for a single series and for the other D boxes, it goes up proportionally. We now get 12 gigabytes per second bandwidth, where we used to get about 5.5, a little bit over 100% performance boost. This is only available for new clusters right now. We're planning on introducing the upgrade soon. As you can imagine, it's easier to write the code for a new data layout than also to write the code for translating the data from the old data layout to the new data layout at the same time. Rather than learn how to change the tires on the bus as it's going down the highway, we introduced new features and we had put them in as retrofits 1 or 2 releases later. Note that small writes are still mirrored. And if the rate at which you're writing to your C nodes isn't high enough to justify filling out full erasure code stripes, we'll pad them to minimize the write latency. The next step, which comes in 5.2, again for new clusters first, is as updates are made to metadata, and of course metadata updates are small updates and mirroring is more appropriate for small in-place updates. We're going to do 3-way instead of 2-way mirroring. This protects us against double failures. It's required for eBox clusters. It won't be available as an installation option for CBox, DBox clusters until 5.3. If we follow our usual cadence, 5.4, 5.5, we'll start seeing that this is an upgrade. Metadata triplication increases resiliency, but nothing comes for free. Writing 3 copies means we have about a 20% performance loss in doing pure metadata operations, like creating 0-byte files. In the real world, it's going to be much smaller than that because that's the worst case. We also see about a 33% loss in metadata space because now we're writing 3 copies instead of 2 copies. That means fewer elements, that is fewer files or fewer inodes per DBox. So if you're writing very large numbers of small files, you may have a decision not to go with triplication. It also puts limits on the maximum amount of data reduction, again, because the amount of metadata space has been reduced. The good news is we added metadata compression in 5.1, so the additional overhead is balanced by the fact we're now compressing this data and requiring less space. The last improvement is specifically for those most demanding applications in the HPC world and in the AI world, where you have a large number of compute nodes that checkpoint. In both of those worlds, the compute servers are not the most reliable things in the world. And so they have 1 to 5% annual failure rates for compute nodes. Combine that with a job that might run for weeks and having to start over again if any of the nodes fail. And the work pattern that's evolved is for clusters to dump their memory, checkpoint periodically, so that if something fails when they have to restart, they can restart at the last checkpoint. For superpods, NVIDIA recommends checkpointing once an hour, and that the checkpoint take no more than 5% of the hour. So we're talking about very large bursts of writes that occur periodically. And the faster you can ingest that burst of writes, the faster the very expensive GPU servers can go back to doing their work. Some of our competitors have been making hay about the fact that vast clusters were somewhat asymmetrical. We could provide service reads much faster than we could service writes. Well, write buffer RAID took that asymmetry down by a factor of 2. Write buffer spillover allows us, when very heavy writes are taking place, to enter a burst write mode. In burst write mode first, the migration process is suspended. We stop copying data from SCM to QLC and consuming the bandwidth on the SCM SSDs to perform that task, which leaves more bandwidth available for writes. More significantly, we create a second write buffer, still using Reed-Solomon erasure codes at 10+2, but now writing those erasure codes across not the SCM SSDs, but the QLC SSDs, because a vast cluster has many more QLC SSDs than it has SCM SSDs. Even though each QLC SSD is slower at processing writes, since there are so many more of them, we get much more aggregate throughput. And again, we roughly double the write performance of the cluster for however long the allocated space in the QLC for this additional write buffer lasts. And so at installation time, we will scale this to last for some set of minutes, typically 5 to 30 minutes. When the checkpoint happens, that additional write buffer is going to fill up. They're all very large writes, so it doesn't create a huge amount of wear on the QLC SSDs because it's the kind of writes that they like. The QLC SSD buffer fills up, the burst ends, and there's a hangover period while the system migrate back on and has to migrate all of the data, not just from the SCM write buffer, but from the QLC write buffer. That hangover period lasts some matter of minutes, and then we're ready for the next checkpoint. Don't apply the performance from spillover to applications like backups that do long sustained writes over many hours. It's a solution for a different problem. So when we talk about performance, we're going to be talking about sustained and burst performance for writes for D boxes or E boxes. And so as you can see, the write performance for both Series and Mavericks Lightspeed D boxes has grown substantially over the last several releases. All of this is just software improvements. No hardware upgrades are available. All of these improvements will eventually be available to existing clusters, but they're available to any new cluster you're selling now without requiring hardware changes.
Yeah, I think that's an important point, Howard, because we oftentimes, hear from our competitors, well, they just doubled performance, and when you kind of dig into it, it's a hardware change. It has nothing to do with the software. These are software upgrades that have kind of led to these kinds of 2x or 4x performance improvements.
So that's it for the architectural changes, and they're relatively significant. The next addition is synchronous replication. So many customers have a requirement for zero recovery point objective. When they write data, it has to be written so safely that if an asteroid falls out of the sky and destroys their primary data center, their data is still safe. And asynchronous replication provides that. For solution providers, this allows them to provide a regional rather than a zonal object storage service, because when we do synchronous replication between vast clusters, it's active. So you have two vast clusters, you create a replication relationship between them, just like you do with our asynchronous replication. And then you declare that synchronization for that folder to be, for that bucket, because this is an S3 feature right now, to be synchronous. Once you've done that, when a user writes to either cluster, that cluster will send that write to its partner. The acknowledgement from the partner will come back to the original cluster before the original cluster acknowledges to the client that the data has been written. So data is, when it's acknowledged, is written to both clusters, and you can write to either one. So this gives us all of the durability that you can ask for. It's right now, it is strictly a S3 feature. We'll be adding support for other protocols in future versions. The part that we have, this is a durability solution. We do not have automatic failover. We haven't implemented a witness service so that we can tell if the link breaks, which of the two clusters should become primary. That's a manual process in the current feature. So it provides all the durability, but not the availability of something like NetApp's Metro cluster. In 5.1, we announced global access, the vast global namespace. And that allowed you to share folders between vast clusters. Satellites serve the shared folders from cache. Writes are proxied to the origin cluster that holds a full copy of that global folder. And we use read and write leases to maintain consistency amongst the clusters. So you can read and write at both satellites and the origin. And note that satellite and origin are per folder concepts. A cluster is not an origin or a satellite. It is the origin or a satellite for a specific cluster. So our Los Angeles cluster on the slide and the cluster in the cloud are each origin and satellite for one of those shared folders, so that the media folder is held in LA. The servers in the cloud read that media, render it, and write their output to the renders folder, which is origined in the cloud, and can then be read at any of our locations. So the directionality is a folder by folder concept. So in 5.2, we've extended global access in a couple of ways. First of all, we're allowing SMB access as well as NFS3 access. More significantly, we're giving you control over how satellites fetch data. In 5.1, satellites only fetch metadata or data on access. And that means that your application has to ask for data, and then there's the latency of fetching it across the WAN. If you know you're going to use the data in some folder at a satellite, you can now tell that satellite to pre-fetch changes to either the metadata or the data and the metadata. And since VAST is a REST-first management model, you can do all of this under control of your scripts through the REST API and tell satellites to pre-fetch data as you've fed them the results of some stage in your workflow. Ultimately, the VAST OS should run anywhere you want it to. Of course, this takes us time to develop. And the next step of that for clouds is to run fully functional VAST clusters in the cloud. Just like e-boxes, the data distribution provides the ability for the cluster to keep running when a node goes offline. That means you need a minimum of 11 nodes. The GCP instance we support right now has 9 terabytes of NVMe SSDs per node. You can build a cluster to scale the cache for that global namespace, however big you want, or to use as local storage.
Perfect. And just a couple comments on this towards the bottom of this slide. So, once again, this eBox architecture with GCP is available to be purchased on their marketplace as a private offer. There was a question earlier in the Q&A. Can we get some more details on that? Yes, that's definitely a planned takeaway. And we'll be posting that information on the partner portal. So appreciate the question on that. For those of you that don't know, Google, a GCP, a private offer, whether it's with GCP or AWS, really just allows a vendor on the marketplace to customize pricing and a discount and payment schedule for a specific customer through a private contract or a private offer. I tell you this because this is not, I don't want you to think this is a low touch or a no touch kind of solution that you should be positioning. I think, in fact, it's the opposite. An ideal use case is going to be where maybe a customer of yours or elsewhere is already a VAST on-premises customer. They're also maybe a GCP cloud customer who wants to be able to leverage this solution for replication and or disaster recovery. And they want this managed under a single global namespace. So that's a perfect kind of use case right there. In which case it's going to be crucial for you to engage your VAST sales team to help pull this solution together with Google Cloud Platform. And then finally, I was able to confirm a couple days or so ago that this solution will be part of Google's Cloud Partner Advantage program. So more to come on that as well. Back to you, Howard.
Great. Which brings us to upgrades to the VAST data store. The first, which is really significant because it's a harbinger of important things to come in the VAST data engine. The whole idea behind the VAST data engine is to help you build event-driven workflows by having things like file CRUD events create. Now I forgot what CRUD stands for. Well, create, delete, update, revise. That's right. R is revise. but when events occur, that those will trigger the execution of functions. And S3 event publishing is the first piece of that to appear when you perform a create or event, because there's no such thing as a revise in S3. That object triggers the creation of an entry in a Kafka topic via the Kafka producer API. So you have an external Kafka event broker, and we'll now tell that event broker when users create and delete objects so that that can trigger future events. Hint, hint, in some future release that I'll be talking about later in this presentation, we'll be implementing our own Kafka API compatible event broker and moving all of this internally. The other big data store change is expending the access control quotas, both capacity quotas and performance quotas through QoS, to tenants as well as folders or users. This is part of the general expansion of multi-tenancy throughout the platform so that we can be attractive to more and more cloud providers. It allows cloud providers to set aggregate quotas, and it leaves user and folder quotas beneath for the individual tenants to use to control their users or customers. In the database, we're extending replication to be database aware. And this is actually relatively significant. So it's just the ability to use vast asynchronous native replication to replicate views that contain tables. What makes this significant is that tables are replicated consistently. When you take a snapshot that underlies the asynchronous replication for a view containing tables, the tables are snapshotted such that any transaction in SQL that was complete is reflected in the snapshotted version of the table. But any transaction that was in progress is excluded. So this is the equivalent of having SQL Server running on your server and using VSS to quiesce the SQL Server, create a consistent view so that you can take a snapshot. But because we own the database platform and the storage as one integrated whole, we can simply take a snapshot and replicate at any point in time and get that consistent view. So all you need to do is set a protection policy on a view that holds tables, and that's going to always create consistent versions of those tables. The other improvement's relatively simple. We've added to the GUI the ability to import tables based on Parquet. You just point the GUI or the REST API at a folder that contains Parquet tables, Parquet files or objects that create a table, and you can import that into a new or existing vast table, reading in all the schema and assorted metadata embedded as in one fell swoop. So 5.3 brought us improvements kind of across the product, some significant changes in architecture, some incremental improvements across the rest of the product. 5.3, which comes later this winter, similarly has improvements across the breadth of the vast data platform. For the data store, the biggest changes that we can talk about today, and remember that these are just highlights, there'll be other improvements that we're not ready to commit to yet. The biggest change in 5.3 is we're going to support block. And we're going to support block IO over NVMe over TCP. A LUN is a file in a folder so that you can take snapshots and so forth. It is, don't get me wrong, we're going to support block, but that does not mean that we are looking for those primary storage, ultra low latency block applications. If a customer is looking at PowerMax and VAST, one of us is in the wrong deal.
Right.
But if you have a customer who has 4 petabytes of data and 50 virtual machines that manage those 4 petabytes of data that they want to host via block, that's what this solution's for. We're integrating the Slurm job ID into the system so that in things like data flows, you can identify who the busiest jobs are, which jobs are creating bottlenecks, because in HPC land, all the jobs are running under the same user ID, and user isn't very useful, so the job ID becomes useful. In the data space, we're going to be expanding application protocol support to include S3 as well as SMB and NFS. We're going to be adding support for NLM locking for NFS3. We're adding performance enhancements. Actually, that should be under data store. We're enhancing NFS4 performance through delegations. In the database, we're adding our own native query engine, support for views, so you can limit which columns users have access to. The data engine adds that Kafka API compatible event broker, a managed thrift broker, support for Spark Connect. And then for cloud providers, we're adding support for MIT Kerberos, per tenant management, the ability to upgrade clusters that are using in-place encryption from internal to EKM controlled encryption, and we'll be bringing the clusters that we have in GCP to AWS. So again, every quarter, Santa brings you all sorts of good stuff.
Good stuff, Santa. Thank you very much. Before we go to next steps, which is really just a very quick slide, I wanted to maybe take an opportunity. There are a few unanswered questions. Been trying to follow some of them. I think we do need to. Christina, perhaps you can come on stage and show us how. There's a couple that we might want to just kind of put on the screen and kind of share with a larger group. Looks.
Yeah, so there was a couple of questions that came in, and I know we have some experts backstage as well, so feel free to come in and answer those if that makes the most sense. I know some of them have been answered throughout, so I'll put a few on the stage. This one came in earlier in the session. By combining the C nodes and the D nodes containers onto the same physical box, haven't you changed the DS architecture? There's no more disaggregation. Let me just share that as well.
Yeah, and I think Howard did answer it. I think he answered it in his own.
Answering it because I hadn't figured out where the answer button was yet.
Yeah. So what he said, everything is still shared. Compute capacity have been somewhat reaggregated, but we still support C nodes plus E boxes and asymmetric clusters with different size E boxes in the future.
Okay, assuming 5.3 will support OpenStack for block, and can we assume Spring 5.3 will be live? And this is from Steve Kliss.
So can we assume that 5.3 with NVMe over TCP will come out in the spring? Yes. Will Cinder driver support come on that day, or will it take some time after that? I don't think we're prepared to commit.
Okay.
Good stuff. I thought there was one more that I'm just kind of scrolling through the questions here. Actually, I think that might have been the last one.
We have a little
Okay.
extra time, guys. I feel like if there's any other questions in the audience, feel free to quickly put those in chat. This is a great opportunity while we have Howard here, as well as some of our product team, to really answer some of your questions live. And look at that. We did just receive another question.
And answering Jonathan Handler's question about non-x86
There you go.
based server platforms. Series runs on the NVIDIA Bluefield DPUs, which are ARM processors. So we do run denodes on ARM in Series today. We have run some C node processes on DPUs as well, but that has not gone as well as we hoped in terms of productization. Advancements in DPUs will hopefully help us there. But, whether the concept of an entirely ARM server as a C node conceptually would work, we haven't seen customer demand.
Excellent. Continue to ask your questions. We got a great team here to be able to answer them. Appreciate the interaction thus far. So kind of wrapping up in terms of next steps, just a few things. As you know, earlier, late summer, we kind of launched the latest Vastronaut certification. That's a level 1 sales certification. It's about 90 minutes. Many of you have already taken that certification and passed that. Thank you for doing that. We've posted a link here, but of course you can find that on the partner portal. I did get an update from our enablement team earlier this morning. We will have the technical counterpart to that level 1 certification ready to go in January. I'm hoping it's the earlier part of January versus the latter part, but we do have a confirmation that our enablement team will launch that in January. So we'll continue to keep you posted, but have a look at the partner portal, and it'll be posted there in the month of January. Listen, as you know, we go after very specific and defined accounts, and they're typically the largest accounts on earth in terms of managing massive amounts of data. We talked about kind of the hyperscalers and the cloud providers here today, but certainly going after the larger enterprises as well, and a lot of those the federal and kind of state public markets as well. So whether it's state and local government or large research universities, we've announced and put those target accounts on the partner portal, though they're there for you. We want to make sure that we're working with each of you and kind of helping to define a go-to-market around those target accounts. So if you're working with those, if you've serviced those customers, have a look at those accounts. We've made it really easy for us to be able to map those target accounts with you through an outside service, a third party software, a company called Partner Tap. So we can give you a free license, and you can basically just upload or work within their software to basically map those accounts with us. And then you let us know that you've done that. We'll have our channel account manager basically plan a follow-up with you where we can start to plan an account plan and a demand gen plan around those accounts with whom we want to align. As always, have a look at the partner portal. There's a lot of good information there, particularly on the right-hand side of the portal. In the quick links area, we'll be publishing the December newsletter next week. A lot of good information there. You can check out Howard's blog, which we've posted a link to that, where he goes into detail around what we covered here today, which was the 5.2 release. And then finally, register now for January's webinar, we actually have a nice code for you. So if you pull out your cameras or your phones and take a look at that code right there, it'll take you to the registration page where we'll register you for a January webinar. So take a moment just to do that now. And then we'll also be doing 2 separate sessions for our international partners out there. So we'll have an EMEA version as well as an APJ version. I think, Christina, keep me honest, but I think that is it.
Yeah, Greg, that was great. Thanks for kind of running through all that. I know we do have this QR code here, but feel free to click in to that link over there on the right-hand side under Doc. You can register that way as well. And this is kind of a continuum of our monthly partner channel series. So keep an eye out and please join us again for a future one.
Perfect. And it looks like there was one more question that I don't know if we got to this one. I don't believe we did. Again, from Jonathan Handler. Thank you for being active on today's call. There you go. Thank you, Christina, for posting that.
For the moment, yes. So
got it. Got it.
It's the event is now triggered in the S3 protocol handler. And so, yes, but that's temporary condition.
Okay, perfect. Should we give it just another moment in case there's any last minute questions that are coming in? Otherwise, I'll go into a long dissertation on how we wind down this call. So in the meantime, once again, thank you for
we could give people 5 minutes back, you know.
We could, and we're going to do that. So I want to again thanks Howard, Dave, Tomer, and Jonathan in the background answering some of those calls or some of those questions. And again, thanks for all of our partners out there that joined us there today. Appreciate your ongoing partnership and the questions and the interest. And we will chat with you in January in our next webinar. In the meantime, we're a couple weeks away from the Christmas season and the Hanukkah season and just the holiday season. So be safe out there. Enjoy time with your family and friends. And thanks again. We'll talk to you real soon. Happy holidays.